Hey guys, happy Friday. Wish I could be there with you guys today, but I am at a conference and thankfully we have Mrs. Jatel helping us out. I am going to give you guys your notes for section 11.6 and it's just 4 parts. So if you guys can all go to your note packet, it's the page after we left off, which should be around page 33 in your packet. So go ahead and get there. And we're going to take some notes. Thanks for doing your homework last night, Mark. I'm sure you did it all out. Really appreciate it. And I just ask that you guys behave for Mrs. Jatel. 4th period, I'm talking to you. Okay, here we go. So we're talking about segment. Yesterday we talked about angles, right? We talked about angles inside the circle, not at the center. We talked about angles at the center. We talked about angles on the circle. We talked about when angles are outside the circle and the relationship between those and their arcs. Today we're going to switch gears and we're going to talk about segment lengths in relation to circles. So the first one that we're going to talk about, you guys already know. I've always called them ice cream cone problems. It's when we have 2 tangents. So that's why up here it says tangent, tangent. Okay, so I have 2 tangents. And hopefully you guys remember when I have 2 tangents from the same exterior point, those tangents are going to be congruent. Okay, and that's always going to be true. So whenever I set up a problem that's just like this, where I have 2 tangents, all I'm going to do is I'm going to set those equations equal to each other. So here, I'm going to do the work over here. We get 5x plus 5 is equal to 10 times x minus 3. Awesome. Okay, so in solving this, guys, this is just an algebra problem from here on out. We're going to distribute out the 10. We got 10x minus 30 on the right side. On the left side, just drop down 5x plus 5. Okay, I'm going to do it all in one step. So I'm going to subtract over the 5x. And on the other side, I'm going to add over the 30. Here we go. Crossing out, we get 35 equals 5x. And divide both sides by 5. We get x equals 7. Ta-da! So that's solving for x. If they want us to find the length, you would then just plug in for 7. Okay, so for example, if I plug in 5 times 7 is 35. Plus 5 is going to be 40. So that's if they ask me for the actual segment length. Okay, so one more example, and then we'll write down the formula. Again, those tangents are going to be equal. So here's my work. I'm just going to set 2x plus 8 equal to 4x. Okay, subtract the 2x over. 8 equals 2x. Divide both sides by 2. So we get x equals 4. And then if they wanted you to plug back in and find the segment length, you can do that. You would get 16 for both segment lengths. The formula, there is no like formal formula other than the fact that they are equal. So for 2 tangents, I would just say set them equal. The other ones will have a formal like formula, but this one really doesn't. We just have to remember that they are congruent, set them equal. You could say tangent equals tangent. That's fine. Okay, so again, this is kind of review. Let's move on to the next. All right, here we go. 2 chords. So this is a chord and a chord. All right, so when I have 2 chords, I want you guys to notice that, that they're split up into 4 parts, okay? Here's one part, another part, third part, fourth part, okay? There's 4 different kind of chunks of the segment. So the formula for this, we're going to write down first, and then we're going to do some examples. The formula for this is part times part equals part times part. Sounds kind of like chapter 8 when we were doing the leg and altitude theorem. Part times part equals part times part. Now, what am I talking about? What parts? On the left-hand side, we're going to use the same segment or the same chord. So this is just one chord. The parts of one chord equals the parts of the other chord multiplied. Okay, so the parts need to be from the same chord. And that's key. Okay. 2 examples for us. Okay, first example. I already kind of highlighted, but I'm going to use different colors here. Okay, so for one chord, we have 8 and 4. See how those are on the same chord? So those are the part and the part. So 8 times 4, those are on the same chord, equals, on the other chord, it's x and 6. So x times 6, or 6 times x. Okay, so 4 times 8 is 32. And I'm going to write this as 6x. Okay, divide both sides by 6. It does not really come out nice. So I can reduce that, though. X is going to be, let's see, divide both by 2. 16 over 3 is going to be my answer. (32) divided by 2 is 16. 6 divided by 2 is 3. That's what I did to reduce. All right, one more example here. Let's see. For the next one, we have from one chord 2x and 3x. And it doesn't matter which chord you do first. It really doesn't matter. So 2x times 3x, notice that those are on the same chord, is going to equal 18 times 3. Those are on the same chord. Okay, 18 times 3 is 54. And on the other side, okay, 2 times 3 is 6, and then x times x is x squared. So here, let's divide both sides by 6. We're going to get x by itself. Okay, I get x squared equals 9. 54 divided by 6 is 9. Square root both sides, guys. We get x equals plus or minus 3, but the negative doesn't work, so we are just going to get x equals 3. Okay? So when I have 2 chords, it's part times part equals part times part. And we're going to move on to the next. Now we have 2 secants. So secant, secant. It looks like this situation where both of these segments go through the circle, okay? So let's write down the formula first. And this one, the formula, is part times whole equals part times whole. Now the question becomes, which part? Do I do the inside part or the outside part? The part is always, always, always the outside part. Always, always, always. Okay? You will never use the inside part, so it's just going to be outside part times the whole thing. Alright, that's the key. Let's do an example. Okay, first example. Here is the outside part, guys, for the left segment here. So that's going to be 7, outside part times the entire thing. 7 plus 6 is 13. Okay? Then outside part times the whole thing, so equals 4 outside part. This whole thing, guys, is 4 plus x. Okay, so 4 times 4 plus x, the whole entire thing. Awesome. So 7 times 13 is 91. Distribute your 4. Okay, 4 times 4 is 16 plus 4x. And subtract over that 16. Okay, we get 75 equals 4x. And divide both sides by 4. And we get x equals, it should be like 18.75. Okay, part times whole equals part times whole. Let's do another. Same idea, guys. Outside part, 6, times the whole thing, which is 6 plus 10, so 16. This is our second example here. Equals outside part 8 times the entire thing, which is 8 plus x. Okay, 6 times 16 is 96. Equals, distribute the 8, 64 plus 8x. Okay, subtract over the 64. 96 minus 64 is 32, equals 8x. And divide both sides by 8. We get x equals 4. Okay, part times whole equals part times whole. And that's for 2 secants. And we'll go on to the last one. Last but certainly not least is secant tangent. Guys, this is when I have one segment that goes all the way through the circle and one that just touches the circle. So a secant and a tangent. Let's go right to the formula. Formula here, kind of similar to the last one. Okay, the formula is part times whole. Again, the outside part. But then we're going to say it equals the whole tangent squared. Okay, so this is for the secant, this first part. And again, we'll write this down first. And the whole squared is the tangent. And again, the part is the outside part. So there's our formula. And it makes sense because there's no way I could do part times whole for the tangent because there's only one part. Okay, so let's do our example here. Part times whole, the outside part is 8 times the entire thing. The entire thing is going to be 8 plus 5x. Okay, so we got 8 plus 5x. Awesome. Equals the whole thing, 12, the whole tangent squared, so 12 squared. Okay, distribute that 8, we get 64 plus 40x equals 144. Okay, and I'm going to subtract over the 64. So it comes out nice. I get 40x equals 80, and divide both sides by 40, so x is 2. Very nice. And last but not least, last example is going to be outside part. Okay, so that's 20 times the entire thing. That whole thing is 20 plus x. Equals the whole tangent squared, so 30 squared. Excellent. Let's distribute this. We get 400 plus 20x equals 900. If I subtract over the 400, 900 minus 400 is 500. So I get 20x equals 500. Alright? And divide by 20. Divide by 20. We get x equals 25. Beautiful. And that's it. So, let this sink in. If you guys need to go back, go back. If you want to look at it again on your own, I'm posting the video in Schoology, obviously. And that's it. So, have a good weekend. 6th period. Miss you guys. Everyone else. Whatever. Just kidding. Miss all of you. We'll see you on Monday. Have a good one.